This is one of the most important aspects of this whole video. Not this part 1, part 2, part 3. This is the most important aspect of all this whole video I've been doing. Now, we are into the aspect of writing molecular orbital configuration. Now, we have two steps involved. The first one is calculate the number of electrons present in the molecule. And the formula for calculating the number of electrons is number of electrons is equal to atomic number minus charge. So you have to know your first, at least your first 20 elements, the atomic number very well. Now, the second step is fill each molecular orbital. Whenever you see this capital M, I'm talking about molecular orbital, fill each molecular orbital with 2 electrons, starting from the one of the lowest energy level. Now, when filling the degenerate molecular orbital, electrons are placed singly first before pairing. Look at what we're talking about. They are saying that now, let me summarize this thing. Let me not speak too much grammar. Do you see this formula that I just wrote here? You need to cram it, please. Cram it, understand it, whatever you need to do, do it, hold it. As far as this course is concerned, this is where all the questions come out from. Now, all you need to know, of course, I said bonding 1s, antibonding 1s, bonding 2s, antibonding 2s. Then you now go to the 2p. We start with antibonding 2px. Then the next one is what? The pi 2py, pi 2pz. Then you now write, because you know we have to write the bonding before we start writing the antibonding. Then this one is the antibonding. And of course, we have to end it with s. So if you can cram this thing, you can understand it, you can commit it to memory, whatever you can do. Because over the years or from experience, I noticed that those that understand this formula understand the course so easily for them. So first of all, just understand this thing first. And the step number 2 is saying, you will first fill this one 2, because they are the lower energy level. From this place to this place, you can just, when we are writing the electronic configuration, you start seeing it. You'll be feeling 2 here, 2 here, 2 here, 2 here, 2 here. But when you come to this, when filling degenerate orbital, which is from here, they are the same energy level, degenerate. It means that first, you cannot put 2 here, 2 is not possible. You have to first fill them singly, 1, 1, 1, 1, before you now come back to pair them. That's what we're talking about. Now, let's go to an example so that you can understand what I am talking about proper. There's no time right now. Now, in case I now come and said, write the electronic configuration. Let me write it. Let me write it, please. Now, if I ask you to write the molecular orbital electronic configuration for hydrogen, right? Now, hydrogen, you have to first get the number of electrons, right? I want to calculate my number of E. And the first thing I'm going to do is, what is the atomic number for hydrogen? Remember, we have H2 here. Now, the atomic number of hydrogen is 1, but we have 2 hydrogen. So 1 plus 1 minus this H2 here. Are you seeing any charge? You are not seeing any charge. This is an atom, so there's no charge. So minus what? 0. So the number of electron is 1 plus 1 should give you 2e, because 2 minus 0 should give you 0. So the number of electron is 2, right? Now, if I want to write the orbital electronic configuration, you already know this formula. This is a standard formula we follow. This is a standard. It cannot change. So if you want to now write the orbital configuration, remember they said fill this with 2 electrons starting from the one of the lowest. This is the lowest. So if you want to write the molecular electronic configuration for hydrogen, it's just 1 sigma 1x. Then of course they say start with 2, right? We'll put 2. And that's the total. You cannot proceed and say antibonding, because the total number of electrons is 2. So the electronic configuration for hydrogen is just this. This is just the answer. Are you seeing it? This is just the answer. And most times I say, in part 3 of my video, I said immediately write bonding, write antibonding. If you like, you can still write this thing like this, antibonding 1x, and leave it like this, because you do not put either 1 or this. It simply means it's 0 like this. But for the sake of confusion, this is the electronic configuration of hydrogen. Now, I will solve a lot of examples so that you understand it more. Now, what if I ask you to write the electronic configuration of, let's say, lithium? I mean that you could have copied all these things out by now. Now, if I ask you to write the electronic configuration of, let me say, lithium. Now, for you to get a number of electron, the atomic number of lithium is 3, right? But there are 2 here, the atomic. So we have 3 plus 3. What is the charge? 0, right? And so what you have is 6 electrons. Now, if you calculate the total number of electrons, oh my God, I went and cleaned this thing. I have to repute that value because I want you to be looking at it so that it will make sense to you. Now, so the total number of electrons for this is just 6, right? The next thing is for you to carry this thing, fill it. First of all, remember the lowest energy level, we'll start filling it 2, 2. But whenever we come to degenerate, if you reach here, because I can ask you to do that of the 20, that's when you start reaching this place. You start filling it singly first before you pair it this place. That's why I decided to demarcate it. But apart from it, from here to here, just start filling 2, 2. So this is 6 electrons. All you need to do is just bam, you already know this formula. So this is sigma 1x, you put 2. Then the next thing is anti-sigma 1x, you put 2. The next thing is what? Sigma 2x2. So this is 2 plus 2, 4 plus 2, 6. Just like writing electronic configuration 1s2, 2s2, 2p something. That's how this is. That's how it's working here. Do you understand? Because if you want to write electronic configuration, we start doing all this 1, 2, 3. So this is S, and then S, S. So you have something P, P. So P, P. I just want to tell you that it's the same thing. So this is 4, this is P. You know, we used to have something like this in electronic configuration. That's the same thing that is happening here. Are you seeing it? But this one, this is the main formula you need to know for this. So once you know this, you have known the whole trick. So this is the electronic configuration, the molecular electronic configuration for this. This is 2 plus 2 plus 2, which is what? 6. Let me do more examples so that you can understand me. Now, what if I ask you to do that of the lithium? This is lithium 112. If I say that of the lithium 2, let me say 2 plus. Now, if I want you to do that of the lithium 2 plus, of course, you already know that we have to get the number of electrons. And so the atomic number for this lithium is 3, right? The same thing we did there, 3 plus 3. Now, we have a charge of plus 1. So this is minus the charge, which is 1. So this is 6 minus 1. That will give you 5 electrons, right? The next thing is for you to proceed to write it. All we have to do now is to proceed to write it. Can you pause the video? Can you pause the video and get the answer? So all we need to do right now from our standard, here, so it's not going to be sigma 1x, antibonding sigma 1x. The next thing is look at our standard, then sigma 2x. Then you now start putting 2, 2 is 5 electrons. That means here must end with 1. So this is the answer for this one. Can you see that the thing is so easy? The thing is so easy. Now, I want to do more, like whenever you check your textbook, you start understanding that this is so easy. So easy. What about if I ask you to do that of the helium? Helium is 2. So for you to get the electron, helium is 4. The atomic number of helium is 2, right? So 2 plus 2 minus, is there any charge here? Of course no, so 0. So this will give you 4 electrons. And so if I ask you to write the molecular electronic configuration of that helium, which is 4, is simply sigma 1x2 and then 1x2, right? That is 6. So if you take your Chem 1 3 table, you notice that even that from number 1 to 20, there's a place they do it. Once you understand this, it's so easy for you to now do the rest. I will drop more video on this. Stay tuned.